You know, we tend to think of our solar system as this neat, orderly, clockwork place. But what if I told you its history is actually a 4.5 billion year long story of pure violence, chaos, and a whole bunch of cosmic impossibilities? Seriously, it's a story filled with events that by all rights should never have happened.
And let's just start with the biggest mystery right in our own backyard. For a planet our size, our moon is, well, it's freakishly large. It's this weird outlier that's had scientists scratching their heads for centuries, and its very existence just defies any simple explanation.
So the thing is, the answer to our oversized moon isn't just one single event. It's actually the final piece of a much larger, much more violent cosmic puzzle. To really solve it, we've got to first understand the other impossible problems our solar system had to overcome just to exist in the first place. Okay, let's dive.
All right, so our first puzzle takes us way back, even before the sun was a star. Back when our solar system was nothing more than a giant, slowly spinning cloud of gas and dust.
This all boils down to a concept in physics called angular momentum. Now, the easiest way to think about it is to picture an ice skater. When they pull their arms in, they spin way faster, right? Well, as that giant pre-solar cloud collapsed under its own gravity, it should have done the exact same thing, spinning faster and faster and faster. It's a fundamental law of physics.
But here's the paradox. If that cloud had kept all of its spin, the outward force, the centrifugal force, would have been so immense that it never could have collapsed down to the size it is today. You'd have a sun spinning like a crazy top, and Jupiter might be orbiting way out past where Neptune is. It just doesn't add up.
So, where did all that spin go? That right there is the angular momentum paradox. Somehow, our solar system managed to hit the brakes, shedding a colossal amount of spin. And look, while scientists have some really good theories, the exact mechanism, yeah, that's still one of its greatest unsolved mysteries. Next up, let's talk about how the planets themselves were actually built. Because even after that big cloud collapsed, the building blocks of the planets face their own, seemingly impossible hurdle. Planet formation starts incredibly small. It's kind of like cosmic dust bunnies, seriously. Tiny particles of dust and ice, smaller than bacteria, just started sticking together. And these swirling eddies in the gas disk acted like giant cosmic blenders, helping them clump up into larger and larger chunks.
But here's where things get really hairy. When these chunks grow to about a meter in size, about 3 feet across, they hit a huge problem. They become big enough to feel a serious headwind from the gas all around them. This slows them down and sends them spiraling right into the baby sun to be vaporized. And this happens fast, within just a few hundred years. They're just gone.
So how on earth did anything survive this death spiral? Well, the leading theory is what you could call a cosmic Peloton effect. Just like cyclists in the Tour de France draft off each other to save energy, these meter-sized rocks gathered into huge swarms. They shielded one another from that deadly headwind. This brilliant collective strategy let them survive long enough to grow into what we call planetesimals, bodies finally big enough to be safe.
Okay, so we've cleared that hurdle. But even then, where the planets formed was absolutely critical, especially for building our solar system's 800-pound gorilla, the planet Jupiter.
This boundary, which we call the snow line, wasn't just some line in the sand based on temperature. Oh no. It created a cosmic traffic jam on a planetary scale, and it set the stage for a giant to be born. So here's what happened. Picture this. As all these icy particles spiraled in toward the sun, they'd hit this line and instantly vaporize, turning from solid to gas. This created this massive high-pressure zone, like a cosmic dam, that trapped enormous amounts of icy material that was flowing in behind it. This exact spot became the perfect, incredibly fertile ground to rapidly build a gas giant like Jupiter. Okay, so let's recap. We've got a solar system that somehow managed to slow its spin, and we have a way for planets to grow without falling into the sun. Now we can finally go back and tackle our first and biggest mystery, the moon.
So the moon isn't just big. It's chemically, well, it's weird. Compared to Earth, it has a tiny little iron core, which means it's almost entirely made of rock. Plus, when you look at the Earth and moon together as a system, they have an enormous amount of spin. These were the big clues, the smoking guns that scientists had to work with.
For years, people came up with all sorts of ideas. Maybe Earth spun so fast it flung the moon out, or maybe it captured it from space. But the theory that fits all the evidence today is a cosmic hit and run of an absolutely unimaginable scale, involving a lost planet that we've named Theia.
Now, the collision wasn't head-on, it was a sideways swipe, a glancing blow. This impact was so powerful it vaporized the rocky outer layers, the mantles, of both Earth and Theia. But it allowed their heavy iron cores to merge together. All that vaporized rock was blasted into a debris ring around Earth, which, and this is the wild part, in just a few thousand years clumped together to form our moon. And what about all that spin I mentioned? Get this. Right after that massive collision, a day on Earth was only about 4 hours long. Can you even imagine? The impact gave our system an incredible amount of angular momentum. Over billions of years, that energy has been slowly transferred to the moon, pushing it farther away from us and slowing our planet's rotation down to the 24 hours we know today.
You would think that after all that, things would finally calm down, right? Nope. The chaos didn't end with the planets forming. Even after the major construction was done, the solar system was still a wild, shifting, and pretty dangerous place, littered with all the leftover building blocks.
These regions are basically cosmic leftovers, pristine material from the very dawn of the solar system. The asteroid belt, for instance, is what's left of a planet that Jupiter's immense gravity just never allowed to form. Then you have the Kuiper belt and the super-distant Oort cloud, which are these huge reservoirs of icy bodies, the source of all our comets.
And get this, the planets themselves didn't even stay put. Current theories, like one called the NICE model, suggest that the giant planets all shuffled around in the early solar system. This planetary migration would have flung asteroids and comets absolutely everywhere, very likely causing what's called the Late Heavy Bombardment that pummeled the inner planets, including Earth, about 4 billion years ago.
Which brings us to a final thought. From these cosmic paradoxes and planetary death spirals to a cataclysmic collision that gave us our moon, our solar system's history is one of overcoming impossible odds through pure chaos and constant violent change. It's a pretty powerful reminder that even the heavens aren't permanent. And the story of our cosmic home, well, it's far from over.